Hello. Before we start off today, I would like to fix a few C usage kind of errors, and also compiler errors. First of all, I didn't define. There's some build errors that I missed when I was finishing up yesterday, and let me clean because I was messing around with different compiler options. Okay. So we have conv is undefined. So let's see here. We have kana stats because I didn't include the right file. H. Okay. And then we have some other error, make map.c. That's strange. Why is that suddenly a problem? Make map.c. Um, mapping goes, oh, okay. Because I changed this. There. There we go. Now it's actually a string. Okay, good. Now, we are just changing stuff that we changed in the last commit, more or less. So this is safe to go along with. I mean, safe to simply append into the last commit. Okay, so the fixed name of type def, all these commits are done except for this one, which is work in progress. Also, these ones don't have the correct commit message yet. But in any case, that means that we can add a commit between 1 and 2 here, which fixes the problem I found. And the problem is that I've been using %ld for size of, or for size t rather, in printf formats, and that is not correct. So that only happens to work on 64-bit, or when uh, when size t is so when yeah let me review that. Hold on a second. So okay, I just looked this up. So %L means long, um, and uh, and if size t happens to be the same length as long, same width, then that will work. But if it's not, then it won't work. And in when I compiled with 32-bit mode on my platform, it did not work correctly because apparently size t is 32 bits and size t is long in that configuration. And so yeah, then the D means unsigned. The D means signed, and we don't really want that for size T. We want U. Technically, I mean, it's never going to get that high in practice that it actually matters. But %U is ZU is correct. And I think that I didn't do it before because it was not like C. It was not compatible prior to C99, or it wasn't supported prior to that. But that's probably not a very good reason. I think %LD is just plain wrong. And if there's a compiler that compiles it that doesn't really warn on printf problems, then it's going to go unnoticed. So it's better to just use the correct modern specifier rather than an old and wrong specifier. And later on, if we want to support older compilers, we can just add a preprocessor macro to to substitute in for %ZU. Yeah, let's fix all that. First of all, in the commit that we haven't finished yet, let's see if we're actually using it. No, we don't have it in the commit we're using yet. So let's see. We're going to look for %LD, and I bet every single use is going to be size. So the index is size t. So we're going to fix that percent. Oops. Z. Okay. No, it's ZU. So we're going to say ZU. ZU. All right. And then we got to go to check kanji DB order, and then line 67, and here. Code point. Oh, code point actually is long, so that's correct. Um, and then we have hash map test. 1.5. Okay. It's an LD bucket count. Okay, this is one we just did. Oh, so we can actually fix this without, because I haven't pushed this one yet. So we can keep that. And this is why I remembered that I wanted to fix it, because I was just using it in this last commit. So let's look again. Kanji DB order. That was fine. And setting infos dot count. Oh, check kanji DB order has another one that's not correct. So sort infos dot count. Okay. And then we go to mapping.c, 128. First key I is sign size, so %ZD is correct. And then we've got to go to did I do both here? 133, first key I. Okay, this also has to be fixed. So we'll do ZD, first key I. And next we've got to go to util.c, 151. Okay. And then line is long, so that's already correct. That's fine. So now we're going to commit the hash map test, which is what we just, which is an unpushed commit, because so that can be fixed up. That can be a fix up, and this is a fix up of 3. So h3. Okay. And then for the rest, we let's make sure it still builds. Make. Okay, good. And also test pass. So good. That means we can just go ahead and get our m fix size t and size ss size t printf specifiers with specifiers. Okay. Now we'll run the fix up. Good. Oh, I didn't actually move that behind the commit I wanted to. Let's put it here. Yes. Okay. Suppose it doesn't matter much where I put it. I'm not going to be moving these around at all. As long as it's after something I've already wanted to push. And I haven't even pushed this yet, if I remember correct. But anyway, so now we have to work on the kana stats command. So one thing I want to do, there are these something called ducting, which is these 2 extra slashes that we put after some kana. So here we go. Let's copy this and make it large. Okay, so this has a ducting, which is this / and this has a handucting, which is a circle. And these are things that are kind of like added to change the consonants of the particular character. So this first, this handucting, this one only goes for goes to kana which have the H consonant, so hahihuheho, and this will change it to a P, papi pupepo. This is used in multiple consonants for ka, sa, ta, and this changes and maybe another one, also ha, and this changes it to ga. It changes ka to ga and sa to za and ta to da and ha to ba, and these are now there's 2 ways to encode this in UTF-8 or Unicode, and one is to have the ductang and hanductang as separate characters which compose, in which case it should be an extra 3 bytes here, which gets added to the ha. and sometimes it's actually not. Sometimes it's combined to the same character. And so I want to figure out what iconv does, which is what we're going to be using most of the time. And if it doesn't use the if it iconv does not use if it does not store them separately as separate characters or composing code points, then we don't have to support it, because and that will save us like 4 or 5 lines of bit shifting kind of code. So I think we have the this this file that we were working on. Oh, yeah, here we go. Let's take this. So I want to extract a these kind of characters, right? So let's convert this to shift.gis conv dash or here echo then icon slash to shift.gis from UTF-8. I don't know if that worked. Okay, I think it did. So we'll do hex dump dash c. Okay, and so it has, this is 2 bytes, this has 2 bytes, this is 2 bytes, this is 2 bytes. So it looks to me like it does not use, oh, so okay, so this is when we send it to shift.gis. So if we convert it back, that's what we want to see if it actually uses composing characters. And 3 bytes space, 3 bytes space, 3 bytes space, 3 bytes. So no, it does not use combining characters apparently. I don't know now. Maybe if shift.gis does use combining characters, if you like force it to use it, then when it converts it back to UTF-8, it will use it. That could be possible. So I'm not sure how to do a search for this. Let's see. So if we do like, maybe there's something in icon about like decomposition. No. Okay. Let's do this. Something like kana ducting. I'm not sure how to say composition in this context, the technical term for that in Japanese. So I'm just going to use English. Here. Let's do this. Let's do and then we'll do it more or less in Japanese. Ducting X and it's not finding it. Let's see, what character do it? W X Y. Oh, I'm way off. This should be ta. I'm drawing a blank on which what the input code is. Maybe it's just a little too early in the day. Hold on a second. Okay, I remembered. So we'll do this. Ducting composition Unicode. All right. So just composition. Okay, so this apparently is what we want. 309A. So let's try that. So if we do printf 309A. Oh, oops. F. Okay. And then we put a ka here. Okay, good. That worked. Oh, that's separate. That's handakteng. That's putting handakteng on ka, which is not exactly what we want. Let's make this ha. But it's nice that the terminal knew how to render that properly. I've used terminal emulators where that didn't work properly. So anyway, pa. Okay, now we can do stump dash c. Make sure that it's coming out correctly. Yes. So and if we do iconv dash from shift or to shift just. Okay, 82 CD. All right. Now, if we actually did this thing, ka with handakteng, I wonder if how that would look. Would that work? Even work? 82A9. I guess that does work. Or icon dash from shift. Oh no, it didn't work. There was an error message which I didn't see. Okay. Legal input sequence at position 3. Oh, so the position 3 refers to the new line, I guess. The new line is not represented in that manner. No, this is right. This really is what that really is the error for the handakteng. So illegal sequence at position 3. So why did it appear here? Illegal sequence shift jis to shift jis. Oh, I got mixed up here. No, I didn't. So why is this giving me an error? This is ka. So yeah, this should not be an error. This should be fine. I guess that maybe iconv does not understand composition or like han or handakteng composition or dakteng composition. So this is pa, and then if I do iconv dash t shift just, that gives me an error. I was just not seeing it because I was not paying enough attention. Alright, so iconv dash to utf8 or from, let's put it, yeah, so it can't round trip it. It doesn't really know how to handle this thing. But it's correctly formed because I know if I just do this, oh wait, let me get rid of the new line. Yes, okay. So ICOM does not support decomposition, so I'm guessing that decomposition is not used as much as I thought it was. Because if iconv does not support it, then probably I don't have to worry that much about it. So that is 309A. Printf, so iconv. Okay, hex dump dash c. So that means that we don't have to support this. And what is the alternative? What is the other one? Like 9, I guess, would be the dakteng. Yeah. So 309 9 and 309A do not need to be supported, and we can search for that with these two things here. So let's open up kana stats, which we started writing yesterday, and we'll just make a note here: do not support these 9 and A here. Okay. Composition composed dakteng and han dakteng. Okay. Do not support. So, right, now we're getting closer. So what I want to do is I want to go to romaji.h. I want to get the romaji codes. get romaji codes. Yeah, oh, that's interesting. This doesn't actually store the codes in a global array. It it composes them for you. That's quite interesting. So key mapping array. So what I want to do is I want to get this key mapping array and then just kind of turn it into put it into a hash map with 0 counts for each conversion key. In other words, this is going to be like a conversion. This will be no, this will not be a key in the map because it's not compiled in. Oh, but we don't want to include this. So this we're gonna have to add a hack in to not include it. But in any case, we're gonna create a map which just where all the keys are these like romaji entries in the table, and the values are just empty counts, 0 and 0. Then we're going to loop through the input data. We're gonna read through standard in, and we will look for matches in that standard in with this table. And whenever we find a match, we're going to increment the corresponding element in the hash map. And we do have to convert this to hiragana first, and in the hash map, because we're basically storing them separately here. Well, I don't know. Maybe, yeah. We'll store them in the same in the same hash map entry, but in separate in like separate counts, separate count fields like this. So we only need one hash map. So yes, first we need to like populate this array. Get an array. Let's do struct key mapping array mapping. Then we do get romaji codes. Yeah. All right. And then we got to delete it when we're done, don't we? How do we handle it? Do we really delete it properly every time we use it? Because that sounds a little suspicious. Mapping.c, mapping.c, get romaji codes, mapping populate, get romaji codes. No, we do delete it. We delete it down here. Okay. So we can do destroy array to make sure we don't forget. Mapping. Let's make sure that builds. Yes. All right. So we also have a struct stats map. Oh, let's call this input mapping. Stats map. And we don't need to keep input mapping around when we're done with it, so let's create a separate function to do this. Static void collect potential mappings, and we'll do struct key mapping array const m or input. This, yeah, I'm not sure what a good name is to call this because I don't want it to be too long. Input map. Inputs. Yeah, let's just go with that. And then we do the destination, which is a stats map. Out. Okay. Collect potential mappings. Right. Collect potential mappings. Address of. Oh, but the whole point of this was that we don't need to keep this around. So we put it here. We don't need to pass it around, rather. And then we destroy it. We populate it. Right. Okay. Stats map. Stats equals that. Then we do potential mapping stats, and destroy array stats. Okay. So let's choose a size. So the size of the stats map will be it'll be the size of the input mapping times 2. We'll just use that. Now we're not going to have it as big as the input mapping because the input mapping has separate entries for hiragana and katakana, but I think that's probably okay. So we'll have so that means that if we make it if we make the output map have twice the number of buckets as the length of the input map, then we will have 50% full rate by means of the fact that we are doubling the bucket count, and we'll also have beyond that we'll only have 25% mapping because we're combining hiragana and katakana, so we'll have a 25% fill rate. But I don't know if that's ideal. Maybe we don't need it that much. We'll just let's do yeah, let's just have it equal. We'll have the get romaji codes, and then we'll do init hash map out to mapping dot count, right? Then we do destroy array. Oh, did I use the right naming convention for destroy? No, I didn't. Did free hash map. That doesn't work. Okay. So let's make sure this builds. We're going to fix that. We're going to fix the naming. Destroy array mapping 24. Okay. Let's fix that. Oh no, mapping. Mapping, input mapping. Mapping. Alright. Input. Okay. 68. Stats map has no member name L. Stats map. Destroy array. No, we want to. Let's just. We're going to fix the name. Okay. The name. So we're going to fix hash map utility, and fix name of type def. It's not need. Don't need to worry about that. We're going to have a fix up of this commit, is what I'm trying to say. So just instead of free hash map, we'll do destroy hash map. Git grep free hash map. All right, hash map test. Destroy hash map. And then we do util. Let's see, hash map test. Destroy hash map. Free. Destroy. Okay. Let's try again. Good. So now we're going to do a fix up of number 4, hash map utility. Okay. Good. All right, now that that's fixed, hash map. Okay. Yeah. Okay, if we do a make, that'll still work. Now, so let's implement this. Collect potential mappings. We're going to yes. Let's let's do size t. I don't know if I like using size t so much. I mean, isn't uint 32 good? Or int 32? Int 32. Let's do that. For I equals 0, I is less than input mapping dot count, and I plus plus. And then we're going to convert the katakana to hiragana if it is like that. Otherwise, we just add it. And then we also check to see if it's kanji. And if it's kanji, then we just skip it. So let's, should we just do that first? It's going to be kind of tricky to figure that out. romaji.h. So I think what I want to do is we'll have a we'll have like signed flags here. Flags. Let's do this. We'll just say int include kanji here. Right? We're gonna have to make this flexible, I believe. romaji.c include kanji. Then we do get romaji codes. Int include kanji. This is probably going to be the easiest way to actually make it work. So yes, let's do this now. Okay, if not include kanji, then we can return early. Otherwise, we've got to include it. So we will say, okay. Let's see here, how do we want to handle this? Append copied mapping. Romaji. What does that do? Key map array codes and romaji entry. So it's array size of, okay. So grow array by growing the array and adding a new entry. It looks like so yeah, let me see if I can just call this function if that's good enough. But it takes a romaji entry. That's not really very good. So we'll say let's call it static void append mapping. We'll do struct key mapping array codes, and we can do a char const ridge and char const convert. Okay, and see your string copy. Go array by. Okay. Now we only call this twice, so maybe we don't really need we don't need to pass this whole we don't want to pass this whole thing. We only call orig and conv on it, so we can just take this. Let's do this. Orig and conv. Darn, it doesn't fit on one line. That's okay. Copy mapping. And copied mapping. Okay. Dot orig and romaji I dot con. Oh, this doesn't look right actually. I think there's a problem here. If use as is, then we add that. This looks wrong. This looks like we have a problem here. This is just adding the same mapping 2 times rather than using the katakana, just converting it to katakana. Oh, it's converted kind of down here. Okay. All right, that's fine then. So we'll do .orig and romaji.conv, right? And here, okay. Okay. Then we can say if include kanji, then let's do, we can just inline this. We will say append copied mapping codes, and orig is this, and then we have this, right? And we're just going to use that. Now we could also make something, do something a little bit more. Oh, look at this! Everything is out of katakana except for this one. That's interesting. So that seems a bit overkill to have this flag, which is only true once. Oh well. So we could say that like we only include these if include kanji as true. So I was thinking maybe just add an extra field here, which is true if it's a kanji, but not sure if that is justified. That just feels kind of like I don't know. Seems a bit too roundabout, to be honest. So let's finish adding these. Okay. Append copied mapping. Oops. Right. Oops. Okay. Okay. Oh, we need to change this so that it's actually correct syntax. All right. Yeah, that looks good. So we're going to have to fix all the usages of that function. So let's do get romaji codes and kana stats.c 25. Okay. Include kanji. 1. Collect potential mappings. So include kanji is 0. Okay. We're going to have to put that in a separate place as well in mapping populate, mapping.c. Get romaji equals 1. Append copied mapping. GC 492. Okay. Yeah, I'm not sure why I called it copied mapping. It's kind of a strange name. I think just append mapping is good. All right. Append mapping. Right. I guess because before it was copying the data out of this romaji map, but now it's obvious that it has to copy it. I don't know. Yeah, I don't know how I like that. Pen copy mapping. Just, yeah, it sounds a bit verbose. I'll just call it a pen mapping. No, it didn't work. Click kanji. That's interesting. What happened? Orig and convert. Kanji keys. Let's see what happened here. Include kanjis. Pen mapping. So is that because the flags are not correct? So it was 1 and 0 for the flags, and over here 1 and 0 mean use as is and auto katakana, which is not true. Okay, so that should be fine. Bridge and convert. Mapping destroy. Get romaji codes. Get romaji codes. Yep, we only have 2 usages of it. Test expected out. Free kanji keys. Dot test output. Okay. Well, it looks like our test served the purpose. So I'm guessing what happened is somewhere along the line we were using this romaji map without actually just raw and as is, and free kanji keys output. So that's not really what we want. We don't want to we want to process it, right? We don't want to just kind of we just don't want to iterate over it raw. So okay, let me think about this for a second. Okay, so we're going down a bit of a rabbit hole and shaving yaks, but it seems like we're going to have to fix the romaji module so that it can actually be parameterized based on like preferences and based on a set of flags. I've been wanting to do this. I knew that I wanted to do this before today, but I didn't realize that it was going to be so pressing of a need. Um, the thing is, I don't really like the idea of kicking it down the road any longer, because as we can see, kanji distribution. Let's see, where was I before? In kana stats, I guess. So yeah, include kanji is, I mean, the alternative is to like we don't want to include kanji in the counts, right? That's going to make the stats hard to read. So we want to exclude the kanji, and so that means we want well, we could like now we could just filter them out manually in this loop, but the problem with that is that that code is eventually going to be useless because I do know I want to add these flags. So we're a flag system. Now, so I've decided that I want to add this flag system and not push it out any further. Otherwise, I'm going to do unnecessary work. Now, if we look at romaji.h, it's actually not that. It's not. I think it's not going to be super straightforward because we have all these functions that well, yes, we basically have to add parameters to all these functions, which is like which takes the like a context object. So it's basically going to be object oriented now, unfortunately. Or we can we can just have a single set of parameters like this, and we just make it all like global. So we have like initialization routine, which kind of sets up the romaji module as like just with the arguments you've given it, and and then if you can reinitialize it later on as you like. I guess that's probably how I want to do it. So I don't. Do we have a romaji test yet? Yes, we do. So okay. So this is what I guess we'll do. Let's kind of stats.c. Okay. Let's just keep what we've had here. Let's commit mend kana stats.c. All right. Now we have this stuff, and this I guess we're gonna want to keep. Does this build? I think it builds, but it doesn't pass tests. So let's change this to branch to kana stats, right? And we're going to check out number 2. No, that doesn't work. Written by checkout, right? Okay, so let's call this parameterize romaji module, right? Now we're going to rebase this module. Yeah. Oh, do we need to do that? Why don't we we'll make a new branch for kind of stats. So we'll just do checkout to branch kind of stats, right? H2 git reset. didn't want to set the branch where I expected it. Kana stats. Then we do checkout dash h and get checkout dash b kana stats. All right. And oh, we need to call this romaji, I guess. And kana stats is going to be rebased onto number 3. So we'll do checkout kana stats, then get rebase I, and we're going to get rid of the, oh wait, we want to get rid of the fixed size. No, what do we want to get rid of? We want to, okay, this is what we want, I guess. Wait, where did that commit go? That I kind of stats here. Cherry pick. Not sure how that got lost. No, that's not what I wanted. H2. Okay, check out H2. Then we do a cherry pick. All right, good. That's what we wanted. Now, okay. All right, now that I'm done confusing myself, let's have romaji. So we're going to start doing this. So we need to go to H. We're going to have a we'll do init romaji, and we'll have include kanji flag. And if it's not set, yeah, let's see, how do we want to handle this? I guess we can just require that init romaji is called. All right, so let's do let's create a romaji.c. We'll do void init romaji int include kanji. All right. And we can do a static int include kanji. This is going to be start to 0. Int start gets starts in it. Just do okay. So we only want to check the romaji, the like hard-coded thing here in this function. We don't want to use the romaji outside of it. So we can see here. Okay, and then kanji. Let's do this. Okay. Equals include kanji. Okay, that's easy enough. We don't want it in here. We don't want this to be an argument here. And we can check include kanji here. So, defaults to 0. So now we got to check all the usages of the romaji thing here. Because basically we just don't want this to be target non-sorted string, get free kanji keys. Okay. Yeah, so how are we going to do this now? Okay, uses is mark used. Okay. So now I guess key mapping array can just be a like this struct static struct key mapping array codes. Okay. And if we initialize it, then we want to destroy that array. codes, right? And then we're going to repopulate it. We'll call this init romaji codes. Right. Init romaji codes. Okay. Oh, here we go. Append mapping does not need to be past codes anymore. Append mapping. Okay. Kanji. Let's do that. Right. Codes, 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 and codes. Okay. There we go. Looks good. So key mapping array. And then we can do we can call this instead struct key mapping array const. Get romaji codes. All right. Romaji codes. Int. Int init. So we do init equals 1 if we get all the way down here. We probably don't need this to be in a separate function. We can just inline this, I think. Let's put it inside here. Init romaji, right? Destroy array. Okay. Romaji include kanji. Okay. Then we can have this struct key mapping array const get romaji codes. Then we do return address of codes. Right. Great. So now we've got to, we don't need to call this here. And I don't think we need to save include kanji anymore. Let's not save it. And that means we don't need this name hack. And we don't need this here. So we also want to check if it's initialized in a get romaji codes. Yeah. So verify initialized. All right. Okay. Void verify initialized. Void. If not initialized, then it's bug. Romaji module was or must call init romaji. Okay. All right. So the idea is that init romaji needs to be called, but you don't have to call dinit or like free or destroy or anything. That makes things a little bit easier for everyone. So destroy array kanji. Don't need to save that. Size I. Okay. Right. Let's just do this. Let's make this u int 32. Okay. Init. Good, good, good. So now we don't need this thing. We don't want to access this thing anywhere. Okay. Yes. So let's take this and put it down here. Right. Oops. Okay. We don't want anyone else to use it. Right. Um, okay. In it. Oh my jeez. Okay. Now we want to get rid of all usages of this. Looks like it's only used in 2 functions. That's good. All right, so we can do verify initialized. Let's put verify initialized up there. Okay. Oops, caps lock was on. That confused me. All right. Let's see here. Just target non-sorted string. Init. Okay. Okay, so so this is a separate init thing, which I guess, let's see what we can do. We can rather than initialize it lazily, we can just initialize it eagerly. I guess. I don't know how I feel about that, but that's okay. Target stirs romaji nr. In that case, we do need romaji nr, I guess. So maybe it was a mistake to remove that around. Romaji nr. Or here. Let's move it. Just move this somewhere else. We have target stirs. Or we can use the array, the growing array thing. Because this is just an array of strings, I guess. Let's see here. Let's do this. Struct target stirs. We'll do char const. How many consts do we want? We want elements here, and we want size t count and size t alloc. Right. Get rid of that. Okay. If not target stirs.init, then we initialize it. Target stirs. Do destroy array. Destroy array. Target stirs. Right. Okay. And then we do target stirs.init is 0. Good. Target stirs. Or we can just do it eagerly. Yeah, I feel better about doing it eagerly. Let's do that. But then it's kind of mixed in with all this other junk. That's also not very easy to understand. Okay. So then we can do verify initialize somewhere. Initialized. All right. Okay. Stirs, target stirs. Oh, but this needs to be .l, doesn't it? Okay, target strings, dot init. Okay. So, okay, now we need to use the array growing function or macro and grow the array here, element by element. So we do Q sort. The Q sort is fine, although we need to do target strs dot count here. Strs dot init. Okay. Verify initialized. That looks okay. For I is less than codes dot count. Right. Then we take the conversion. Okay, so we do grow array by. Array and grow count. Okay. Grow array by. The array is target stirs and grow by 1. Target stirs dot L I equals 1. Okay. I equals codes dot conv. No, codes dot L dot conv. Dot codes dot L I dot conv. Right. Okay. Good. Car count. So then we do target stirs dot count here. Okay. Get free kanji keys. Now we gotta fix this. Okay. Mark used. Mark used. Do not need to do caps. We don't need to do caps explicitly here because we've already expanded the romaji array so that it's kind of like already interpreted here. So do codes dot count and see codes dot li. All right. romaji.h. Okay, this is getting quite involved. I might have to take a break. And we have romaji entry. Get free kanji keys. Okay, so we're using codes.l, so that means we want to verify it's initialized. Verify initialized. Okay. Okay, then what else? This is mark used. Okay. So we can just inline mark used, I believe. First key offset. Caps. Chart key index. ASCII to upper. Change. Turn C. Okay, this uppercases things. Okay. Mark used. Codes.l. Okay, mark used. We should probably inline this. Oops. Mark used. Okay. don't need caps here. And caps char to key index. Okay. Getting free kanji keys. Now, why is it necessary to convert the char to a key index anyway? First key offset. Oh, because it's filling in this map. Okay. ASCII to upper. That's why. Change to. This conditionally changes. Oops. Conditionally changes ASCII to uppercase. But didn't we already have code do that elsewhere? That doesn't make sense, because that should have had to be done in here. Append mapping. To katakana. Okay. As is auto katakana. Here's that code. So we don't need ASCII to upper anymore. Char to key index. All right. Codes.li dot orig 0. All right. Then we do the same thing here. Codes. Oopsie. Codes.li.orig 1. Okay. String length. Next. Use.m. Use just get free kanji keys. Okay. Maybe that's all I need to do. At least as far as correctness is concerned. I'm sure compilation errors are another problem entirely. Init romaji. Let's just see what happens. Am I on the right branch? Yes. Okay. Okay. Here we go. Let's start from the top. Function declaration isn't a prototype. Get romaji codes. Get code. All right. Function. Okay. Mapping.c. Okay. Mapping.c. Mapping populate. Get romaji codes. Yeah, this is a little bit awkward. So I don't need this separate codes thing anymore. Get kanji codes. Let's open mapping.h. We don't really need this. Well, maybe we should keep it. Get romaji codes. I mean, I guess it would be easier to keep it and then copy it when we use it. Mapping. Keep mapping. Oh yeah. Because we're gonna grow it, right? We're gonna initialize it with a romaji, then we're gonna add more stuff. So, okay, I see now. We probably should keep this as it is. So we'll do code. Oops. Void. Romaji. Okay. Get romaji codes. All right. verify initialized. Okay. Then we do grow array by, oh, I don't know if we want to do it that way. We don't want to grow it all in one go, because then you're going to lose the amortized constant time append. So we will want to do this to uint type I do for I is 0, I is less than codes dot l count I plus plus. Okay, I guess, do we just need a mem copy here? Let's see, what is romaji.h codes? Short code array, key mapping array, key mapping. Okay, key mapping is a kind of flat thing. So we can just do a mem copy. Mem copy. Oh no, but we need to grow it first. Grow array by codes. Mem copy codes. Codes dash L I. Or no, codes dash L. I'm going to do codes dash count minus 1. And copy that from our own codes, codes dash L I, comma size of codes dot L. Okay. Yeah, so I guess we need to take the address of that. All right, good. Get romaji codes. Good. Let's try this again. 322. Okay. X3alloc array. Let's see what happened here. Query by. What happened? Expansion line 351. Target stirs. Okay. No, no, wait. That's not a problem. Stirs. Array. Passing argument 1 of X3alloc array discards const qualifier from pointer target type. Oh, this shouldn't be a const, should it? At least not in that sense. I believe that's what we want. Because the only thing we don't have access to change is the characters themselves. Error code undecared. 396 links codes dot orig. Okay. Codes dot li. Okay. Used. Yes, used has to be like that. Memset forward. All right, let's try and not recompile for every single error we fix. Append mapping. By saying by no, I can type. All right, let's try again. Oh, look, not that many errors left. 500. Orig is that. Orig. Okay. Let's see. Okay, 500. Invalid argument of type that. Okay. Let's try again. 531. Okay. Well, we got some test failures, but no compiler failures. Let's see. Bug at must call romaji. Recipe for target. Target has failed. Okay, now we have to initialize romaji wherever we use it. Or we can just, if we verify initialize, so if not initialize, then we just do init romaji include kanji equals 1. Is that too lazy though? Do we just want to fix where we don't initialize it? Maybe that's better, because this could get more complicated later on. Yeah, I guess it shouldn't have that many places to add the initialization call. So let's try and find all of them. First key. The thing is, oh, that's why I need to do it this way. Edit hash map. Which test failed? Input test. Okay. So here we go. Romaji include kanji is 1. All right. Next, we have a failure in input test first. Okay. Let's see what the problem is. Okay, so it's not including kanji, I guess, because it's just assigning some other characters here. Assigning other characters in the shifted numerals row. So we call this, what test is this? Input test first key K. First key K. Ergonomic sort. Why is that happening? Input. Maybe do make romaji test. Check that this works first. That did not work. Okay, romaji test.c. All right. Include kanji is 1. All right. Okay. Free kanji keys. Why am I including commands? How come I get free kanji keys, but I'm not... Oh, free kanji keys is a command. Okay. That would explain it. Let's go to free kanji keys. Free kanji keys. And we do init. Alright. Make romaji test did not work. Free kanji keys output. Diff free kanji keys. Okay. Okay. Let's see, what is the failure here? Okay, it's not realizing that these are free, or the expected is that they should not be free. Right. Yeah, they're not. They should be free, but they're not. Romaji test free kanji keys test output dot test out contains So it looks like expected does not include them, but actually does include them is what the problem is. Okay. Let's open, oh, I don't want to add extra lines for no reason. Free kanji keys. Okay. Right. So the problem is that let me check the test output, expected test output, and free input test. No, romaji test dot free. Okay. Okay. So we don't expect it, but it is. Right. We don't expect it there. It should not be considered a free character, but it is. All right. Make input test. Okay. So it's in the actual output, right? So, and it should not be. So it should not be considered a free key because it is used by romaji. So let's see what's going on. Really, this should not be too difficult here. Include kanji is, let's actually look at free kanji keys, the command, and we do call include kanji as one. So we should be adding it. Romaji, append mapping. Okay. Okay, append mapping. All right. Then free kanji keys. Cause free kanji keys. Char to key index. Char to key index here. So maybe this is not giving it the correct key. Well, no, it's here. This should be resolving properly. Key index. Index. Mappable character count. Index. Memset. Okay. So free character key index map. Now is pen mapping correct? Maybe it's not copying original converted. Yeah, that looks fine. I was just thinking maybe the order of these two arguments are incorrect, but no, they're fine. And include kanji in it. Now include kanji is not saved anywhere. Let's see. You know what, we don't need to, I just realized we don't need to save init, right? We can just say if, we don't need to save init for this thing, not, just count the elements. There we go. Oops. All right, that's good enough. Now free kanji. Oh, and actually we don't need to store init either. We can just check the codes codes dot count. Codes count. All right. Append mapping. Get free kanji codes. Kanji keys, get free kanji keys. Verify initialized. Okay. Okay, how are we gonna approach this? Because just reading the code, it's not immediately obvious what's going on or why it's not working. But it is figuring out all the other free kanji keys properly, which kind of makes me think that everything is that it's. I mean, it's basically processing the the romaji array correctly, but it thinks that the kanji keys are not. It thinks that the kanji keys are free, but they shouldn't be. Get free kanji keys. Oh, I guess this is correct, right? So that we don't expect them to be free, or we. I'm confusing myself. All right, because I remember this code was hacky in the first place. So maybe let's make sure we agree with the fact that it's failing. So the output says that let's see, make input test. All right. This is the actual output. No, I want to run the romaji test. There we go. Actual output is that they are free. Okay, that doesn't make sense. Doesn't make sense that they are free because we are populating it right here. So we have append mapping, free kanji keys, get free kanji codes, kanji key count, get free kanji keys. Okay. Codes.li, orig. Okay. All right, let me think about this quietly for a minute. I'm going to pause the recording. Okay, so just looking at the code is not really getting me anywhere. So I'm going to do some printf debugging. I'm not too proud about, but the I'm not really so sure if I can get the well, let's do GDB. Let's clean and let's do a debug build. XG3, I think. Make C flags new sort. Okay, so we'll do new sort and run free kanji keys. I think this okay. Exited normally. All right, so let's set a let's see if we can do it again. Free kanji keys. Okay, good. So now we want to set a breakpoint at romaji.c at line 513. I think that's the right index. Okay. And by the way, the funny thing is that it looked like some of the kanji keys were properly being marked. By the way, let me actually check that again. So we got new sort slash sort. So do that as input test. So make input test. Let's do the diff. I'm going to do the diff actually. Input test. So so 5 go and 10 ju and 2 ni. Those are all correct for some reason. I'm not sure what happened there. So if we do make romaji test, we also have I'm guessing that some of these will be correct. So let's do a diff. No, it's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe those are actually assigned properly because they're numbers and they're very common, so they get assigned to those keys somehow. Um, anyway, let's see. Let's run free kanji keys. Okay, so codes.count. All right, so codes.l. Let's look at the last element here. Orig is 0. Okay, that doesn't look right. Oh, so it's parenthesis and 0, 0, and then conversion. This, okay, that looks okay. Print codes.l 366. That also looks correct. Okay, so it's correct down here. I mean, it's adding them properly. Print codes .l 360. Okay. So let's go to free kanji codes or keys. Get free kanji keys here. Let's So I guess we want to stop. We want to set a breakpoint here when I is equal to 360. So let's do. So how are we going to do that? Hold on a second. Let me figure out how to set a conditional breakpoint. Okay, so it looks like we just have to add this, the condition after the at the end of the B command. So we'll say break on romaji 385 C385 if I is equal to 360. Then we continue. Oh, that didn't work. What happened there? Breakpoints. See, file romaji line 514. 5 1 also set. Three. 385. Also set a PC 5 DC04. 1 3 at. So breakpoint 1. Not sure why that's not working. That's confusing. Reference conda. Let's see here. GDB show existing show breakpoint. You can see these breakpoints. You can see info breakpoints. Display both the breakpoints you set explicitly. Info breakpoints. Okay. Keep Y. Already hit one time. Only if I 360. Breakpoint. Not sure how to read this. Number 2. Okay, only if I is equal to 360. Breakpoint keep Y at romaji.c. Yeah, that looks correct. I don't know why that's not working. 385. Let's try again. Run free kanji keys. Romaji. Okay, continue. Okay. Looks like we're getting somewhere. 302. Why is it stopping here? Character index. Okay, next. Print ch. I thought C would. Well, why do I have a breakpoint there? Oh, because I have it on line 1. So how do you say turn off breakpoint? GDB turn off breakpoint. Disable breakpoint 6. So we want to do disable disable 6. Okay. Continue. Well, that didn't work. Free kanji. What's going on? Free kanji keys. I equals to info breakpoints. All right, disable. What did I disable? Did I disable the wrong one? No, I disabled 6. Not sure what that's about. Get free kanji keys 385. Up only if I is 360. Oh, maybe it's because we're returning early here? Does that have something to do with it? If first key off is -1, then return. Oh, this should be continue. Maybe because I inline something. Or because the order of stuff was changed, and so now it's not going to romaji test. Okay, good. Good. There we go. So yeah, so we were returning early for some reason, and I'm guessing that that bug existed even before, but we never noticed it because it was ordered properly, or no, mark used. Yeah, so we inlined something. That's why we inlined something. We were returning. Now we have to continue instead. So we have to be careful next time we inline a function. Let's run all the tests. Okay, it's looking like ran more tests successfully, but not all of them yet. Keyboard test. Keyboard test. Okay, so I want to do mapping populate. Let's see here. Let's do init romaji here. Kanji include kanji equals 1. Okay, last rank contain test. Not enough args. All right, edit last rank contain test. Okay. All right. Oh, last rank contain test. So it's running a command here. So really, it's the user command that should be running that should be doing the initialization. So we do last rank contained. This is okay. Parsing arguments, and we eventually go down to here. After we parse the arguments, we should probably do this. Make j. Okay, we're getting there. Default mapping, make map test. Printf, make map. New sort. Make map is a command. It is okay. Make map. Okay, here we go. All right, there we go. All the tests pass. Okay, so we are running input test. Yeah, I don't know if I really added the init romaji calls where I really want to, but for now that's fine. Okay. Codes. Get romaji codes. Okay. So this looks fine. We added this target strings. We made this into a global array, so we don't have to use the nr value so many times. and I'm guessing that we don't use that value at all. Edit romaji.c. Yeah, we just inlined it here. Okay, so we is target not sorted string. We change that. Um, we kind of change the way we're caching the results. And now this is a global value. It was a global value before, but now it's slightly different. And then we have this. This is now global value, which it was not before at all. This is the actual mapping of romaji to uh, romaji to the kana. ASCII to upper. Free kanji keys. Okay, size TI. Get free kanji keys. Let's see. Edit. Well, we inlined a few functions because we no longer had to pass this caps thing. Now the caps is done kind of implicitly when we initialize the romaji. It implicitly converts some of the romaji to katakana and makes them capital letters. And yeah, so that looks pretty good. So now we can let's commit this, but I don't like the name of include kanji like this. I think I want to call it include kanji numerals. Let's see here. So let's do a find and replace or sort xarg sed dash I dash e s slash include kanji and call it include kanji numerals. Okay. All right, that looks better. Good. All right, now it's been almost 2 hours. I should probably take care of some non-coding things for now. And so today we basically made romaji module parameterizable. And that means that next time we are actually ready to do this kind of stats command. Oh, but you know what? We didn't actually write any tests for this. So we should probably write tests for the fact that we did the no, actually we don't really need to, because the we're going to write tests against kana stats, which will basically handle this for us. We'll be testing this include kanji code path when we write tests for kana stats. So for now, I'll think we'll call it done, and thank you for watching.